These are the notes for AP Calculus on the topic of limits and piecewise functions. So when finding a limit at a breakpoint of a piecewise function, and remember what the breakpoints are the x values where the piecewise function domain is split up. In this case, it'd be -3 and 4. So when you're finding a limit at a breakpoint, you must find the left and right hand limits separately. And that's because at -3, there's a different function that applies to the left of -3, where x is less than -3, as opposed to here, this function, part of the function applies where x is greater than or equal to -3, to the right of -3. So since two different functions apply on either side of -3, that's why you have to find the left and right hand limits separately. They require the use of two different pieces. So let's take a look at the first one, the limit as x approaches -5. Well, -5 is not a breakpoint, so all you have to do is look at the domain for each piece of the function and see where does -5 fit. Is -5 less than 3, between -3 and 4, or greater than 4? And it's less than -3, so you substitute -5 in for x. That gives you -10 over 0, and then when you have a number that's not 0 over 0, that indicates you have a vertical asymptote. In this case, at x equals -5, what we substituted in. And when you have a vertical asymptote, remember you have to find the left and right hand limits to determine if they're infinity or negative infinity. So we've already got a left hand limit here and a right hand limit here. So from the left and right, on both of them, notice there's a negative sign. It's a -10 on the numerator, so it goes on the numerator on both of these. And on the denominator, from the left, you would typically choose something a little bit less than -5, like -6. Substitute in the denominator, and from the right, you choose typically something like -4, a little bit larger than -5, right, on the denominator. However, you can use a little shortcut here, and notice it's squared, right? So other than -5, anything else, other number that you plug in there that doesn't give you 0, and you square it, it's always going to be positive. So if you notice that, that's a little shortcut. And negative divided by positive, that's going to be negative infinity. Also negative divided by positive, negative infinity. So since both sides approach negative infinity from the left and the right, then they're the same. So that is your general negative infinity. All right, let's take a look as x approaches -3. So as x approaches -3, notice -3 is a breakpoint. So we cannot start with the general limit here at a breakpoint. You have to evaluate the left and right hand limits separately first. So the way you do that is, as x approaches -3 from the left, we'll just think, which piece applies to the immediate left of -3? Well, this one does. It says x is less than -3. So you substitute -3 to that piece. It would be 2 times -3 divided by -3 plus 5 squared. 2 times -3 is -6. Divided by -3 plus 5 is 2 squared. -6 over 4 reduces to -3/2. Now let's find the limit as x approaches -3 from the right. A little plus sign indicates from the right. So from the right, which piece applies to the immediate right of -3? And that's this piece where x is greater than or equal to -3. Now this piece applies to the right of -3, but too far. It's really to the right of 4. So this applies to the immediate right of -3. So we use that piece and substitute -3 in for x. So it'd be -3 squared minus -3 over -3. -3 squared is 9. The negatives cancel out, so it's plus 3 over -3. So that's 12 divided by -3, which is -4. So in this case, the left and right hand limits are different. They do not equal the same value. So your general limit, cross out the equal sign here, does not exist. What this would look like graphically, to help you see what we really are finding here, is as x approaches -3 in this function, over here -3, we just figured out from the left, x approaching -3 from the left, it's approaching -3/2, which is the same as -1/2. And notice it doesn't have the equal seal on that one, so it would be an open circle. If you approach it from the left, which is -3/2. And from the right, it's approaching -4, and this has the equal to, so it would be a closed circle. And you can see these two functions, it doesn't meet up at -3, that's why the general limit does not exist. All right, let's take a look at a few more with the same function. Let's look at the limit as x approaches 0. So notice 0 is not a breakpoint, so you just have to use the correct piece here. 0 is in between -3 and 4, so you use the middle piece. So it'd be 0 squared minus 0 over 0. Well, that gives you 0 over 0, and that indicates you have a hole at x equals 0. When you have a hole at x equals 0, remember that means you need to cancel. What's causing that 0 is x. And the method you use here is factoring. You just factor out the GCF of x on the numerator. You're left with x times x minus 1 over x. And then you can remove the hole. The x's reduce out. And as soon as you remove the hole that was causing that 0 over 0, then you can substitute in what x is approaching 0, in this case. For x, minus 1 gives you -1. And notice this was a hole, right? So when there's a hole, what you're finding there is the general limit, what's approaching from both sides. So that's -1. And if the general limit is -1, well, you're automatically figuring out the left and right must also both be -1. Otherwise, that wouldn't be the general limit. Now let's take a look as x approaches 4. So as x approaches 4, 4, notice, is a breakpoint here. So we cannot find the general limit to start with. We have to find the left and right hand limit separately. So the limit as x approaches 4 from the left, you would use this piece. This applies, this is where x is less than 4, so a little to the left of 4. So if you substitute in 4 into the second piece, you get 4 squared minus 4 divided by 4. 4 squared is 16, minus 4 gives you 12. Divided by 4 is 3. So from the left, x is, and the limit's 3. And from the right, as x approaches 4 from the right, that would require you to use the bottom pieces, where x is greater than 4, so the immediate right of 4. So if you substitute in 4 for x in the last piece there, square root of 2 times 4 plus 1, that gives you the square root of 9, which is 3. So in this case, the left and right hand limits are equal, so that means that is your general limit of 3. This time, what this would look like graphically, so it says x approaches 4. So 4 from the left, we got 3. Doesn't have the equal to, so that would be an open circle. And as x approaches 4 from the right, it also doesn't have the equal to. Also approaching 3, it would also be an open circle. So even though neither one has the actual point there, the limit, general limit, is still 3 because they're both approaching 3 from both sides. They meet up. So go one more for this piecewise function. Limit as x approaches 13. So, as x approaches 13, let's look and see. 13 is not a breakpoint, so we just have to look and see which piece 13 applies to, and 13 is greater than 4, so you use the last piece. So it would be square root of 2 times 13 plus 1. 2 times 13 is 26, plus 1 is 27. You get the square root of 27, which breaks into 3 threes. So you can pull out a pair of threes, so you give you 3, and there's 1 3 left over, square root of 3. So that's your general limit, because nothing weird is happening, right? You don't have a hole, you don't have a vertical asymptote. That is just a regular point on the graph. So if that's the general limit, then the left and right hand limits would also have to be the same. All right, let's take a look at one more piecewise function with some different limits associated with it. So limit as x approaches -2. Notice -2 is not a breakpoint, so you just have to use the correct piece. -2 is less than -1, so you use the top piece. Look at -2 plus 1 over negative 2 plus 2 cubed. Negative 2 plus 1 is negative 1 over that 0 cubed is 0. So again, we've got undefined, some number that's not 0 divided by 0, so that indicates you have a vertical asymptote at x equals negative 2. So, as x approaches negative 2 from the left, and then from the right, since we have vertical asymptote, we have to test those separately again to see if they're infinity or negative infinity. Notice the numerator is negative, so both of these you're going to put a negative sign. And then from the left, a little bit to the left of negative 2, a little bit less than negative 2, negative 3, you can substitute in the denominator. Negative 3 plus 2 cubed. And remember, all we're concerned with is whether it's positive or negative. So we have a negative divided by negative 3 plus 2 is negative 1, and negative 1 cubed is negative 1, but we're just concerned with the fact that it's negative. And a negative divided by negative is positive. So this one would be positive infinity. X approaches negative 2 from the left. Now, as x approaches negative 2 from the right, we'd choose something a little bit greater than negative 2, like negative 1 to substitute into the denominator. So negative 1 plus 2 cubed. So you get a negative on the numerator. Negative 2 plus 1 is 1, cubed is 1, so it's positive. The negative divided by a positive is negative. So this, from the right, it'd be approaching negative infinity. And since the left and right limits are not the same, the general limit does not exist. All right, now let's take a look at the limit as x approaches negative 1. So negative 1 is a breakpoint. So remember, when it's a breakpoint, you cannot start with a general limit. You must start with the left and right separately. So the limit as x approaches negative 1 from the left. Well, from the left to the left of negative 1, this piece would apply. So it would be negative 1 plus 1 over negative 1 plus 2 cubed. Negative 1 plus 1 is 0 over 1 cubed is 1. 0 divided by some number is just 0. So from the left, it's approaching 0. And then the limit as x approaches negative 1 from the right, well, you use the middle piece, because this is saying x is greater than or equal to negative 1 to the immediate right of negative 1. So if you substitute negative 1 there, you get the sign of negative 1 times pi is negative pi over negative 1. And the sign of negative pi, remember on your unit circle here, here's 0. Remember, when you go counterclockwise, that's the positive direction. When you go clockwise from there, that's the negative direction. So to get to negative pi, this would be negative pi over 2, and negative pi would be right there. And the coordinates at that point are negative 1, 0. And remember, sign represents the y coordinates, so it would be 0. So it would be 0 over negative 1 is also 0. So from the left and the right, both 0, so now you know the general limit is 0 as well. They are the same. All right, let's take a look at a couple more limits involving the same function here. The limit as x approaches 3. Notice 3 is also a breakpoint. So you can't start with a general limit, you have to evaluate the left and right separately. 3 from the left, well, this piece applies to the left of 3 where x is less than 3. So you'd have the sign of 3 times pi would be 3 pi over 3. Well, on your unit circle there, where is 3 pi? Well, here's 0. Go around here, that's pi. Here's 2 pi. And you just keep going, add another pi. So this is 3 pi, the same place pi is at. The coordinates there are negative 1, 0. The sign of the y coordinate, so that would be 0. Over 3, 0 divided by 3 is just 0. Then as x approaches 3 from the right, or to the right of 3, you would use the last piece where x is greater than 3. So if you substitute 3 into that piece, you get 2 minus the square root of 3 minus 1 over 3 times 3 minus 15. 2 minus the square root of 2 over 9 minus 15 is negative 6. Be careful, you can't reduce the 2 and the 6 here unless you split up the fraction, because this other term here, the minus root 2, you have to divide them all by 2. So, nothing else we can really do to make that any simpler, so you just leave it 2 minus the square root of 2 over negative 6. So sometimes you can get some little more complicated answers like that. But the key thing is the left and right limits are not equal, so that means the general limit does not exist. Now let's take a look at the limit as x approaches 5. Well, as x approaches 5, 5 is not a breakpoint, so just use with the appropriate piece. 5 is greater than 3, so we'd use the last piece there. So we substituted 5 there, 2 minus the square root of 5 minus 1 over 3 times 5 minus 15. So that'd give you 2 minus the square root of 4 is 2. So that'd be 0 over 15 minus 15, 0. So in that case, you have a whole at x equals 5. That means you need to cancel x minus 5 in order to get rid of that whole and figure out what. So let's go ahead and do that. So if we write down what we have 2 minus the square root of x minus 1 over 3x minus 15. Alright, so first, since we have a radical there, to get rid of that radical, to reveal that x minus 5 we want to cancel, you have to use the conjugate. So the conjugate of 2 minus the square root of x minus 1 would be 2 plus the square root of x minus 1. Where we just change the sign in between the terms. And then to balance it out, you have to multiply the denominator by the same thing, 2 plus the square root of x minus 1. And now the numerator with the conjugates, let's go ahead and multiply those out. Remember, with conjugates, you don't have to multiply everything together because the inside and outside terms are going to cancel. In this case, one would give you positive 2 square root of x minus 1. The other would give you negative 2 square root of x minus 1. So the only ones that are not going to cancel when you're multiplying conjugates are the first terms, 2 times 2 is 4. And negative square root of x minus 1 times positive square root of x minus 1. Well, first, a negative times a positive is going to leave you with a negative. And the square root of x minus 1 times the square root of x minus 1 is x minus 1. But be careful there. If you just leave it like that, that is incorrect. The reason why is this negative out here in front applies to the whole square roots, right? The whole term there. So even though the square root cancels out, you still need to leave parentheses around the x minus 1 to show the negative applies to the whole thing, not just the x. And then on the denominator, remember we want to reveal the x minus 5, you can see you can just factor out the 3. Leaves you with the x minus 5. And then we still have 2 plus the square root of x minus 1. Notice on the denominator you do not want to multiply that out because you want that, you already can see that x minus 5. Now let's just simplify the numerator. We first distribute out the negative there. That'll give you 4 minus x and then plus 1. Combine your like terms, gives you 5 minus x. And in order to get it to match up with the x minus 5, if we just factor out a negative 1, negative, that would make the x positive and the 5 negative. Over what you got, the 3, x minus 5, and 2 plus the square root of x minus 1. So now you can take a look at the x minus 5s, reduce out, and so you're left with negative 1 on the numerator over 3, still there, and then we can substitute in 5 into the x that's left, because we now have removed the whole, so we won't get 0 over 0 anymore. We've got negative 1 over 3 times, that's 2 plus the square root of 4 is 2, gives you 4 times 3 is 12, so negative 112. And remember, when you have a whole, what we're calculating there is the general limit. What's the product from both sides? So that's negative 112. And if the general limit is negative 112, that means the left and the right hand limits must also be negative 112. And that concludes the notes for AP Calculus on the topic of limits and piecewise functions.